All right, so when we get started, I want you guys, today is kind of like, it's like a turning point in Algebra 2. It's kind of like a milestone for us. We are officially done with Chapter 3, our systems. So that ends our linear functions that we start working with in Algebra 2. We are now moving into non-linear functions. Chapter 4 that we're going into is the first non-linear function that you're going to be asked to work with. So we're going to be working with harder and harder equations and functions from this point out into the rest of the year. So linears, guys, those were our babies. Those were our degree ones, the most easy equations you could be asked to solve and graph. So now things are going to take a step up. We're going to be starting to work with non-linear functions and equations. So I gave you a whole bunch of equations and functions, and I asked you to identify the linear ones from the non-linear ones. Guys, by definition, if you are a linear function, what form can you be written in? Somebody said it. Y equals mx plus b. By definition, if you are a linear function, then you can be written in y equals mx plus b form. All right. Now, when you are a linear function, m and b get replaced with numbers, like y equals 3x plus 8, right? So when you're looking at a linear equation, another definition is this. Guys, what exponent is assumed to be on x? 1. What exponent is assumed to be on y? 1. These are also called degree 1 equations. They are degree 1 because the highest exponent on a variable is 1. So this makes them the simplest equations you will ever be asked to graph and solve. It doesn't get any simpler than just x and just y. So when now we start working with nonlinear function, the degree is going to go up. There's going to be degree 2s and degree 3s and degree 4s. And the more complicated these equations are going to become. Chapter 4 is going to be all about degree 2s, the next one up. All right? Now, normally, you end Algebra 1 working with degree 2s. But I don't know how much you guys remember from Algebra 1 because I'm pretty sure that's when COVID happened and we went out in March, is when you guys ended Algebra 1. Do you guys remember a thing called the quadratic formula? Negative b plus or minus the square root of b squared minus 4ac all over 2a. Well, that's the quadratic formula. He is a formula that will solve any degree 2 equation, a quadratic equation, and that's where we're heading. Chapter 4 is all about quadratics. And like I said, normally you have been exposed to them in Algebra 1, but I don't know what any of you guys learned in COVID, so we don't know, all right? But that's where we're heading. So let's see, who's linear and who's nonlinear? Is that a linear or a nonlinear function? Mx plus b, baby, we're good. Linear or nonlinear? Linear, mx plus b. Degree 1, right? Just x and just y. Linear or nonlinear? Nonlinear. Guys, who's the highest exponent on a variable in this problem? 2. That is degree 2. That's a quadratic. That's what we're going to start working with in Chapter 4. That's what your equations are going to start looking like that you have to solve and you have to graph. All right, look at this one. Linear or nonlinear? Linear. Switch that around. Negative x plus 7. Mx plus b. Linear or nonlinear? Nonlinear. Guys, what degree is this? This is degree 2 again. That's a quadratic. That's what Chapter 4 is going to start. All right, linear or nonlinear? Nonlinear, it's degree 2 again. We're going to see that in Chapter 4 for the first time. Linear or nonlinear? Right, mx plus b, right? B is 0. That's mx plus b. That's linear. Linear or nonlinear? Nonlinear, this is degree what again? 2. So again, that's going to be a quadratic. That's what we'll see in Chapter 4. And then last, linear or nonlinear? Linear. It's just x. It's just y. Is it in y equals mx plus b form? But could you solve it for y and get it in mx plus b form? Yeah, guys, technically, that's a linear equation in what form? Standard form. Ax plus by equals c. But at the end of the day, you could solve it for y and get it in that form. That's a linear function. All right, so say goodbye, guys. We're done with linears. We're not graphing them anymore. Lines are gone. We're not solving linears anymore. We are heading to degree 2s, degree 3s, degree 4s, higher degree equations. So it's going to get more complicated. All right, let me give you your notes. And then tomorrow, I hope to play that crypto game. 4.
I'm about to cry.
Why?
Because I don't like the color.
Oh, you'll be fine. I had to teach my favorite thing ever in math, factoring. Do you guys remember factoring? Your favorite F word? No? All right. There's going to be another page. I just have it off the printer, so let me just come back. This is page 2.
Oh, this is where like the lines.
Oh, it's good stuff.
I don't think it's hard.
It's not. It's just, it's not as simple as a linear, that's all. All right, you guys are, I owe you guys page 1. This is page 2.
Oh my god.
Thank you.
Oh, I was gonna staple it.
All right.
The parabola opens down the vertex. I did not believe What is the parabola?
Oh, parabola. What's up? Is that you, Brendan, or Paul?
That was me. Can I have the map?
Oh, yes, but I really got advice going right now, Brendan.
Okay, I'll take your advice.
What do you say?
I'll take your advice.
Thank you. Just because there's going to be some important vocab that I don't want you to miss. That'll be helpful for the game tomorrow. Oh, all right, here we go. All right, so I have some vocab and definitions I got to go over with you. I feel bad. I feel like I'm going to make this all sound harder than it actually is, but I apologize about that. It's really not that bad. You just got to get used to the vocab that they use. All right, so chapter 4 is all about quadratic functions, degree 2. So a quadratic function is a degree 2 equation now. So it's not just going to be good old x and good old y. A degree 2 means the highest exponent on a variable is going to be 2. So we're going to be dealing with x squareds now, not just x's. All right, guys, when you solve a linear equation, a degree 1, you get x on one side and numbers on the other. You use opposite operations. It's as basic as solving things get. We minus 4, we divide by 2, and you get an answer like x equals 4. So this was a degree 1 equation, and it got one answer. A degree 2 equation is more complicated. When you set a degree 2 equation equal to something and solve it, you get 2 answers. So the degree is going to tell you how many answers it has. So it's going to have 2 answers, solutions, or roots. Now, roots is a word you have to get used to, okay? Guys, when you set an equation equal to something and solve, this is the answer. It's also called the root. It is the number that satisfies the equation. So in math, we call that a root. Now here's the tricky part. I'll come back to that. Let me say it right now. You're going to see it again. The answers to a quadratic equation can be, when you take a quadratic equation, a degree 2, set it equal to something and solve. There's going to be 2 answers to this. It's degree 2. Here's the weird part, and I am getting ahead of myself. I just want you guys to start wrapping your head around this. When you solve a degree 2 equation for x, you can get a real number as the answer, like x equals 2, x equals negative 5. Or, guys, this is the tricky part. You get an imaginary number. And you're like, what the hell are you? You're going to be introduced to imaginary numbers. When you solve higher degree equations, it's not always a real number that you get. Sometimes it's an imaginary number. So just hear me out. You are going to be introduced to imaginary numbers in this chapter. I know. Who can wait? I hope you sleep. All right. We're not going to see them yet, but some of the graphs are going to show you. Ooh, that would have had an imaginary answer at the answers. Okay. All right. So now that we're working with these degree 2, these quadratic equations, then by definition, you have to be able to be written in this form. And it is the standard form of a quadratic equation. And it looks like this. Y equals ax squared plus bx plus c. Where a, b, and c, guys, they're going to be replaced with numbers. So let me give you an example. Y equals 2x squared minus 4x plus 7. That is a quadratic equation, where a, the number in front of x squared, is positive 2, b, the number in front of x is negative 4, And C, the constant at the end, the just number, is positive 7. A, the leading coefficient, this number right here, the number in front of x squared, he is a very, very important number for us, and you will see why later. But A is very important. So when I talk about A, I'm talking about the leading coefficient. I'm talking about the number in front of x squared. All right? Somebody had a hand up. All right. Or if they don't write it as an equation, guys, they might write it as a function. So instead of using y equals, they use f of x. Equation, function, it don't matter. Y and f of x both represent the output, the y coordinate. All right, here we go. The first thing you're going to be asked to do in chapter 4 is to graph a quadratic equation, create its graph. So you're not even asked to solve them first. They just want you to create its graph. Well, guys, it ain't as simple as just a slope and a y-intercept anymore. It ain't no lie. There are many components that go along with the graph of a quadratic equation. So all I want to do today and tomorrow is get you familiar with all of these pieces. You don't even have to technically calculate or solve anything yet on your own. I just need you to identify pieces of a graph. All right? All right, so the graph of a quadratic equation ain't no line. It is a parabola. Uh-huh. And you're like, what the hell's a parabola, Hardy? It is a U-shaped graph. A parabola. Lines are gone, guys. Kiss them goodbye. We ain't graphing lines anymore. You know what kills me, Steven? When I give this quiz and somebody graphs a straight line. Why? They're gone. We're not graphing straight lines anymore, guys. We're graphing parabolas. Degree 2 equations. All right. So it's going to be a U-shaped graph, and it has symmetry. It literally can be cut in half, where one side is a mirror image of the other side. All right, before I get started, guys, these are all the things that you have to know about the graph of a parabola. It's a laundry list, okay? Some of them come really quick. Some of them are going to work harder to find. All I'm going to do today is I'm going to give you a parabola that's already graphed, and you just have to identify what all of these pieces are. You don't have to calculate anything on your own yet. All right, so if you're going to graph a parabola, these U-shaped graphs, first let me start by saying there's 2 ways this graph can look. It's either going to be a parabola that opens up, like the one I gave you. I chose this as an example. Or it's going to be a parabola that opens down. But those are the 2 things that your parabola can do. It can either open up or it can open down. Those are the 2 graphs you're going to create. All right, so if we're going to do this, the direction it opens, it's either up or down. There is a trick to knowing which one is which. If the parabola opens up, it's because A, that number in front of x squared, that leading coefficient, was a positive number. If A is a positive number, your parabola is going up. So you will know the minute you look at the quadratic equation whether this graph opens up or down. If it opens down, like this one, it's because A, the number in front of x squared, that leading coefficient, was a negative number. Okay, now let's start finding some important pieces. The most important point on the graph of a parabola is its vertex. The vertex is either the highest point if it opens down, or the lowest point if it opens up. So on this graph right here, that is its vertex right there, the lowest point. You know when you graphed a line, the first thing you did was plot the y-intercept and then use your slope to move? That's your go-to guide. You're going to first find your vertex. That's how you're going to start the graph of a parabola, by finding that lowest or highest point. All right? So guys, in this problem, who is the vertex? Give me the coordinates. Who and who? 1, -4. Done. Okay. Then they could ask you whether the graph has a maximum value or a minimum value. Well, guys, think about this. If this parabola opens up, guys, it's going up. It ain't ever stopping. This graph is going up and up and up and up and up until y gets all the way to infinity. It's never going to stop going up. But it does stop going down because that's its lowest point. So if they asked you, does this parabola have a maximum or a minimum value? Do you know the maximum point on its graph? No, but do you know its minimum? Yeah, so this one has a minimum. If the parabola opens up, then the vertex is your minimum value. It is your minimum point. So really, it just depends on whether it opens up or down. If they ask you if it has a maximum or minimum, guys, if the parabola opens down, it's going down forever and ever and ever, and it's never going to stop, all the way to a y value of negative infinity. So you'll never know the minimum, but do you know the highest point on its graph? Yeah, it's the vertex. So when it opens down, you will have a maximum at the vertex. So if the parabola opens down, the vertex is your max. So those questions depend on whether it opened up or down. All right, then they're going to ask you to find the axis of symmetry. The axis of symmetry is this imaginary vertical line. He's really not there, but we can draw him. This imaginary vertical line that will pass straight through the vertex and literally chop your parabola straight in. And it's saying that anything that happens to the right of this line, there is happening on the left side as well. It's this mirror image of itself. Whatever happens on the right, the same thing is happening on the left of that axis of symmetry. So guys, at the end of the day, the AOS, if you will, for short, it's a vertical line. So you're going to have to write the equation of that vertical line. There's about 50% of you that can write the equation of a vertical line, and there's about 50% of you that still can't write the equation of a vertical line. Guys, if that's a vertical line, who doesn't change, x or y? X. And who is the x coordinate on every single one of these points here? That's the line, x equals 1. So the AOS will always be x equals some number. It should be the same coordinate as the vertex, the x coordinate of your vertex. It's passing through the vertex, so that should be the x coordinate that never changes. So they should match. Now the biggest thing with the AOS is it's 1. The AOS is not a number. It is the equation of a vertical line. It can't be a number. It is x equals 1. It is the equation of a vertical line. All right. Then we get into the good stuff, the stuff that I know you all know. They're going to ask you for the y-intercept, right? The point where the graph crosses the y-axis. Guys, it's right here. There's your y-intercept. Tell me right now what point that is. Ordered pair. I want the ordered pair of that y-intercept. 0, negative 3. X has to be 0 because it's on the y-axis, and y is clearly negative 3. So it is 0, negative 3. Guys, if you're a y-intercept, you have an x coordinate of 0, and then some y coordinate. It's 0, 1. Now with a parabola, the parabolas that you are asked to work with in Algebra 2, guys, they will only have one y-intercept. So there will always be one, and it'll just be 1. All right, and then last, these are going to become like the rock stars in Chapter 4. It's all about the x-intercepts. I feel like when it comes to linear equations, it's all about the y-intercept, b. But when you start working with higher degree equations, the x-intercepts kind of become the more important values to find. All right, so guys, if I ask you to find the x-intercepts, that's the point where the graph crosses the x-axis. How many times does the graph cross the x-axis on this parabola? 2. So he's got 2 x-intercepts. He's got one right here, and he's got one right there. Those are the x-intercepts, right where it crosses the x-axis. So can anybody tell me what ordered pair that is? Negative 1, 0. And then what ordered pair is that? 3, 0, right? X is 3 when y is 0. So if you are an x-intercept, you have an x value when y is 0. All right, now this is really important. The x-intercepts, like I said, they're going to become the rock stars, the ones that we're always going to be after in many, many sections in Chapter 4. They have some nicknames. I'm pretty sure I've already given you some nicknames for the x-intercepts, but let's go over it again. Guys, if you have a quadratic equation, right, and you want to find his x-intercepts, then you're going to look for x when y is who? 0. So basically, you're setting your equation equal to 0 and solving. You're letting y be 0. So when you find the x-intercepts, you are solving for x when the equation equals 0. So we call the x-intercepts the zeros. They're going to be the x values that make the equation equal 0. So they're called the zeros. So if you're ever asked to find the zeros of a graph or the zeros of an equation, guys, you are literally being asked to find the x-intercepts. You are being asked to find the x values when the y coordinate was 0. All right, well, remember what I told you? When you solve an equation and you get an answer, then that answer is also called a root. If you make the equation true, then you are a solution, you are a root to that equation. So when you set an equation equal to 0 and solve, and let's say you got x equals -3 and x equals -1, because you're going to get 2 answers, it's degree 2. You're going to get 2 answers now. These are the numbers that make this equation true. These are the roots of that equation. So they're also called the roots. And I think Delta Math is going to go back and forth between calling them x-intercepts and roots. They are the same thing. The roots are the x-intercepts, and I need you guys to know that. And then in pre-calc, all I do is call them zeros. Find the zeros, find the zeros, find the zeros. You are finding the x-intercepts, okay? So just know those are 2 nicknames for other names that x-intercepts go by. Go ahead. Jay?
I think we do this one day.
Yeah, this is what you will spend, if you go to upper level math, you will spend 80% of your time finding zeros, which are finding x-intercepts. Okay, here we go, let's do it. Let's do it. I cut out the middle page of your notes because you just didn't need it. Let's go right to the examples. Let's try and make some of this make sense. All right. So in the game tomorrow, I'm going to give you a parabola as a graph. And I'm going to ask you questions like, who's the vertex? Who's the AOS? Who's the x-intercept? Who's the roots? Who's the y-intercept? And as quick as you can, you want to answer those questions, multiple choice, you know, the book it, and then you're going to keep on going. All right? All right, so let's try. Let's get some practice in. Here's the graph of a parabola. Guys, clearly this one opens how? It opens up. Since it opened up, you automatically know, was A positive number or a negative number? A must have been positive. Again, you didn't see the equation, but you know if that parabola opened up, then he had a positive number in front of x squared. All right, does this parabola have a maximum or a minimum value? A minimum, right? It opens up, so it's going to go up forever, but it clearly stops right there. So it has a minimum, and we're going to come back to that. It has a minimum value. All right, now I want the vertex, that highest or lowest point. Probably what I would say is the most important point on the graph. Guys, it's right there. Now, these are not centered. If you can picture, guys, that's 0, 0. Here's your x-axis. Here's your y-axis. Here's 0, 0. So who's that point right there? -1, -9. That's your vertex. Perfect. Okay. Now, can we go back to that minimum and maximum again? So if they're asking you if the graph has a maximum or minimum value, guys, we already said it's clearly got a minimum. But when it comes to who is that minimum, they're really asking you, how low did this graph get? What was the lowest number that lived on this graph? -9. So the y-coordinate of your vertex is really who that minimum is. It was a minimum, and it's y equals -9. It happened when x was -1. But when it comes to who is the lowest number that this graph could possibly spit out, it is the y-coordinate -9. All right, the AOS. I want the equation of that imaginary vertical line that goes right through your vertex and chops the parabola in half and says whatever's going on the right side, the same thing's happening on the left side. So guys, I want the equation of that vertical line. Who did we say never changes on a vertical line? X, and who is the x coordinate that it passes through? It is the line x equals -1. It should match the x coordinate of your vertex. Guys, every year I have students that go, it's -1. No, it's not. It's not a number. It is the equation of a vertical line. All right, the y-intercept, the good stuff. It crosses the y-axis right there at what ordered pair? 0, -8. Done. All right, now I want the x-intercepts, the roots, the zeros, if you will. Guys, here's your x-axis. How many times does this parabola cross it? 2. It crosses it right here and right there. Remember, the x-intercepts are iffy. Maybe it crosses once. Maybe it crosses twice. Maybe it doesn't cross at all. All right, so now I want the coordinates of that point right there. Here's where x is 0. What ordered pair is that right there? -4 and 0. Done. All right, now I want the coordinates of that point right there. That is the point 2, 0. Now on the game tomorrow, it's multiple choice. So if I ask you for the x-intercepts or the roots or whatever, you know they're putting 0, 2. Do not pick 0, 2. You know 0, 2 is a y-intercept, not an x-intercept. If you are, an x-intercept, then x has a value and y is 0. All right, last thing. Delta Math is not going to ask you this, but our book always makes it come back in this section. And pre-calc will always talk about domain and range. Do you remember at the very beginning of chapter 2, when we started functions, we had to identify domain and range. Domain was always asking for the what values, x's, and range was always asking for the y's. So guys, right now, when they ask you the domain and range, they are literally asking you, what are all of the x values that live on this graph? And then the range is what are all the y values. I'm just telling you right now, there are way too many to list. So you're not going to be able to list them. So we're going to have to figure out a way to write them. The good news is the domain is the same answer for every single one. The domain of a parabola is always the same. It's only the range that changes. So guys, when I ask you what the domain is, I'm literally asking you to tell me all the x values that live on this graph. Well, guys, if I plugged x equals 0 in, he spits out that y value. When I plug in x equals 1, he spits out that y value. When I plug in x is 2, he spits out 0. When I plug in x is 3, now mind you, this parabola goes on forever. When I plug in x is 3, there's a y value that goes along with it. When I plug in x is 4, there's a y value. When I plug in x is 5, there's a y value. So guys, think about it. Since this graph goes on forever, can I just keep plugging x values in and creating more points? Yeah. So what's the biggest x value that lives on this graph? Infinity. It goes all the way to the right. And then I can do the same thing over here. If I plugged in -1, I'm getting that y value out. If I plugged in -2, I'm getting that y value out. If I plug in -3, I'm getting that y value out. If I plug in -4, I'm getting 0 out. If I plug in -5, there's a point up there. It's going to go on forever. So can I keep plugging x's this way in and create a point on the graph? Yeah. So the x's go all the way out to -infinity. So the x's that live on the graph of a parabola are all of them. Every x value in this world lives on this graph. So we say the domain is all real numbers. So I'm going to give you a fancy way to write that. So we're going to say it's all real numbers. And the way they're going to have you write that in pre-calc is in interval notation. So all you have to say is that x is going to be any number from -infinity to +infinity. So you're going to write it like it's an ordered pair. -infinity, +infinity. Those are the x's that live on this graph. Any number you want is on that graph for x.
Why can I not draw that?
All right, it's sideways 8. All right? In fact, I'm telling you right now, every single parabola has a domain of all real numbers. Unless we make it some real world application, and it would only make sense for x to be a positive number. But in its raw state, the domain is all real numbers. All right, now the range is different. The y's, guys, look at the graph. The y values are going to go all the way up to who? Who's the biggest y value on the coordinate plane? Infinity. So we don't have a highest number for y, but we clearly have a lowest number for y. Who's the lowest y value this graph ever got to? -9. And then all the other y values were what compared to -9? Bigger. So we're going to say the y values are any numbers that are greater than -9. And then because -9 was the vertex, it can equal it. That's still a point on the graph. So now the y values, the range, will be either y is bigger than some number or y is smaller than some number. And then all those y's live on the graph. All right, delta math won't make you find them, but I'm telling you, that's a question that's going to come back up, domain and range. All right, let's try it again. New graph. We got a new parabola. Again, it's not centered. All right, guys? So here's 0, 0. We got a y-axis and we got an x-axis because they're definitely not centered. All right, I want to know, silly question, if this parabola opens up or down. It's going down. Since it opened down, would A, that number in front of x squared, that leading coefficient, be positive or negative? Negative. All right, does this parabola have a maximum point or a minimum point? Maximum. And we're going to come back to that. All right, the vertex, the highest or lowest point we're working with, is clearly right there. Here's 0, 0. What point is this? 3 and 2. The vertex is 3, 2. All right, now, if that's the vertex, to the right 3 and up 2, who was the highest y value that lives on this graph? 2. So the maximum value is y is 2. It is the y-coordinate of your vertex. That is the highest number this graph ever gets to. Remember, y always tells you how high or low something is, so it's the y-coordinate. It happens at x equals 3, but that maximum value is 2. All right, the AOS, that imaginary vertical line that goes straight through your vertex and cuts your graph in half. Who is the equation of that AOS? Who doesn't change? X, and who is the x-coordinate on that line? 3. X equals 3. Somebody's going to put 3 on a quiz, and they're going to get marked wrong. It's not a number. All right, now I want the y-intercept, the good stuff. It clearly crosses the y-axis right there at what ordered pair? 0, -7. Now, guys, on the game tomorrow, I do want to warn you, some of the axes count by 2. So it's like 2, 4, 6, 8, and they'll be numbered. So just be careful. It's not like 1, 2, 3, 4, 5 on every graph. All right, now I want the x-intercepts. Go ahead, Cole.
What is the x-intercept right down on the form?
Okay. Because in the real world of quadratics, do you think the x-intercepts are always these beautiful whole numbers? No. On delta math tonight, I'm like 99% sure they're always whole numbers, but they're not always going to be. All right? So when you look here, if I go to get the x-intercepts, the roots, the zeros, how many does this graph have? 2. It crosses there and there. Okay. I want those ordered pairs. Because we don't live in a perfect world, guys, they're not always going to be whole numbers. So all I need you to do right now, because I didn't give you an equation to solve, so you can't calculate them, I just want you to guess, estimate. So if this is 0, 0, this is 1, this is 2. Give me a number in between 1 and 2 that could have been. 1.5, I love it. So let's say that is 1.5, 0. Just estimate a decimal in between those two numbers. I will give everybody full credit as long as it's decimal in between. All right, this was where x is 3, 4. Guys, give me a number in between 4 and 5 that x-intercept could have happened at. 4.5. Do we know if that's 100% accurate? No, but it's a good enough guess. So now 4.5, 0. So guys, if somebody had said 1.3, I'd give it to them. If somebody said 4.8, I'd give it to them. If somebody said 5.1, you're wrong. That's not in between 4 and 5. All right? All right, now I want the domain and range. The domain and range. The domain is always who? Negative, infinity, positive. The x's that live on this graph are all real numbers. But the y's, the y values. Guys, clearly, who's the highest y value that lives on this graph? 2, and then all the other y's are what compared to 2? Less than it. So we'll say the range is y is any number less than or equal to 2. And you're done. Just try and do one more before Bill cuts me off.
So when it's down, it's the opposite of the range.
Yeah, if it's down, y is less. If it's up, y is greater. All right, here we go. Last one. Because I need you guys on your A game for this game tomorrow. All right. this parabola open? Up or down? Clearly up. Guys, if it opened up, that means A was positive or negative. A was positive. That number in front of x squared. You haven't seen it yet, but we know that's true. Does this parabola have a maximum value or a minimum value? Minimum. We'll figure out who that is. Maybe you already know. I'm going to come back to it. Who is the vertex, guys? The absolute lowest point on this parabola since he opened down. I mean up. X is 1. Y is 0. 1, 0. Okay. Now let's go back. Guys, if that's the point 1, 0, what is the y value at your vertex? So that's the lowest number that ever comes out of this graph. So what is the minimum value when y is 0? I want the AOS. I want that imaginary vertical line that goes straight through your vertex and chops this parabola in half. Who is it? Oh, I thought you were saying.
AOS.
Do you know it?
Yeah, it's the one.
It is x equals 1. Go ahead. What was your question?
Do you have to write like min and then it's y?
On the game tomorrow, it might say minimum y equals who.
Can you write that on the test?
As long as you know it's a minimum, I'm fine. I will specify whether I want the value or not. All right, I want the y-intercept. Who's the y-intercept on this parabola? 0 and 2. The x-intercepts. Guys, here's your x-axis. How many times does this parabola touch or cross the x-axis? So he only has one x-intercept, one root, 1, 0. Who is that point right there? 1, 0. So your vertex is your x-intercept. And there's only one of them. Who's your domain always going to be? All real numbers. Negative infinity to positive infinity. The range. Low y values. Who's the lowest y value? And all the other ones are what? Above him, so that's greater. Y is greater than or equal to 0. How do we feel?
Right.
Are we okay? It's a lot to take in. These are new graphs that we're going to have to use to. Tomorrow's game should be quick, repetitive questions. Who's the vertex? Who's the AOS? Who's this? And it's multiple choice, but they can always trick you with multiple choice, all right? I'm a little worried about our ordered pairs. X first, Y second. All right. For the love of God, Steven! Are you going to be on time tomorrow?
Oh, yeah.
All right. Oh, guys, your homework is on Delta Math tonight.
The Dungeons and Dragons Club will be meeting today after 2:30 at Theater 1. Come join us. You must have your
Oh my God, I was sledding and I totally forgot when I got home.
Club meets today.
We did a lot of sleigh riding today. I'll look at them today. Okay? I'm so sorry. I totally forgot. Like, I totally forgot. There's other ways.